Let's talk about numbers in this lesson. So, the type of numbers we're going to talk about, the group of numbers, are natural numbers, integers, rational numbers, irrational numbers, real numbers, and prime numbers. So, let's start with natural numbers. Natural numbers are the set of numbers which are positive, and it starts from 0 and then it goes on forever. So it would be 0, 1, 2, 3, and then it will go on forever. And it's usually denoted by an n, and the set of numbers would start at 0 and then would go on forever. Integers are similar to natural numbers except that it contains negative numbers as well. This concept is it's going to be useful for programmers. It's highly used in computer science, and they deal with this set of numbers a lot. Those of you who will pursue computer science in the future will probably hear about this a lot. Anyways, so let's start with 0 like we did before, since integers is very similar to natural numbers, and then we will go on towards the positive section, and then this will go on forever. And on the negative side, it's -1, -2, -3, and this will go on forever. And usually this is denoted by a z, and there you go. That's a natural number and an integer. The next one is rational numbers. Rational numbers are the numbers that can be represented by fractions, but the decimal, when they represent as a decimal, there is a stop to it. So what is it? Let's see an example. Suppose we have the number 1/2, which is half, like half a bread or something. And if we represent it as decimal, it will be 0.5. Now it can be represented as a fraction. Also, there's a stop. It's not 0.55555. It doesn't go on forever. It actually stops at 0.5. And let's look at another example. Just to do another example. If we have 53/100, the decimal number would be 0. Okay, let's typing it 0.53. Okay, so it's represented as a fraction and there is a stop to it. It's 0.53 and it doesn't go on forever. Irrational numbers are numbers that goes on forever, and there are some really, like, these numbers are very fascinating and people have done a lot of work on this. Some of the examples are pi, then Euler's number, which is E, and then a golden ratio, which is represented using I don't know what it's called. Anyways, so the number is 3.14159, and this will go on forever. There is no stop to it. And then the golden ratio is 1.618, I think, and then it goes on forever. And then for Euler's number, it is 2.71828, and then that goes on forever. Yeah, so those are some of the irrational numbers, and whatever we have discussed so far can be summarized or compiled into real numbers. So real numbers is all, real numbers is all together. So everything together would be the real number. We're going to look at the real number space in the number line later, which would be more clear when we'll combine everything together. So the next thing we're going to discuss is prime numbers. Prime numbers are numbers that can be divided by itself and one only. So the number 1 is not considered a prime number. The mathematicians have decided that. What is considered a prime number is 2, 3. So why is 2 considered a prime number? So let's look at 2. Can it be divided by itself? Yes, 2 divided by 2 can be done. 2 can it be divided by 1? Yes, it can be divided by 1. So 2 is a prime number. Let's look at 3. Can it be divided by itself? Yes. Can it be divided by 1? Yes. Can it be divided by anything else? No. 3 is a prime number. Let's look at 4. Can it be divided by itself? Yes. Can it be divided by 1? Yes. Can it be divided by anything else? Yes, it can be divided by 2. So 4 is not a prime number. So as you can see, all the numbers in the number line can be divided by itself, and it can be divided by 1. But when it can be divided by something else, that's when it becomes a prime number. So let's go on. Let's look at a few more. 5 can be divided by itself. Yes. 5 can be divided by 1. Yes. 5 can be divided by anything else. No. So it's a prime number. Let's look at 6. Can it be divided by itself? Yes. Can it be divided by something else? No. Can it be divided by 1? Yes. Can it be divided by something else? Yes, it can be divided by 2, and it can be divided by 3. So 6 is not a prime number. So that's the basic concept of a prime number. So the last thing we want to look at is the number line. I have drawn an example of a number line over here and marked them. As you can see, there is a 0 in the middle, and then on the right hand side it goes to 1, 2, 3, 4, and so on. It goes on forever. On the left hand side there is -1, -2, -3, and then so on. It goes on forever on the left hand side. And in between there is like a number 0.5 or 1/2 in between -1 and 2, -1.5 or -1 over -1/2, basically -1.5. And then there's some irrational numbers: golden ratio, Euler's number, and pi. So let's try to see what we have learned so far over here. If we just consider like the whole numbers, which is 0 and 1, 2, so on, and if we start at 0 and then go towards the right hand side, it will be the natural numbers. And then if we actually look at start 0 and then go towards the right hand side and also towards the left hand side, and only consider no fractions, just consider 0, -1, 0, 1, 2, 3, 0, -1, -2, that's integers. And now let's have a look at the yellow ones over here, yellow numbers, which is like fraction. So these will be rational numbers. Rational. And if we have a look at the green ones over here, the golden ratio, Euler's number, and pi, these will be irrational numbers. And in between there would be sometimes some prime numbers. Suppose 3 is a prime number, so is 2. Those are prime numbers. Now if we consider all of them together, let's consider all of this together. It goes this side and this side. This is real number line. All of the numbers that can be in this number line are called real number line. So that's it for this lesson. Let me know if I missed anything, and if something requires more clarification on something, let me know. I'll try to make a video on that as well. Thank you so much, guys.